Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope you are ready for today. We have a great show planned for you with the one, the only, Mr. Ralph Bond. He, of course, is our science and tech trends correspondent who goes out and finds stories that, don't always make the headlines. And let's face it, especially with how crazy the headlines have been the last couple of days, yeah, I bet you that I could probably get an elephant by you without you noticing. It's crazy time out there. I hope everyone out there is safe. And hey, let's take your minds off it just for a little bit with computer and technology news. And this is going to be again kind of focused on the advance, the research, and really the stuff that hopefully will bring a lot of benefit in the near future, and it's really hopeful. So I'm really happy to have Ralph here. Before we get started, computeramerica.com, that's where you'll find everything, including the fully functioning show notes. I'm happy to announce that we have found the workaround for that, and looking forward to that. That's going to have links, that's going to have all of Ralph's points, and on top of that, the articles that he pulled from. So if you want to check out more yourself, be more than happy to. So, computeramerica.com, live video stream, podcasts, all the old stuff, and of course, social media links. Give us a like, give us a follow. Now, all that being said, let's go ahead, jump right into it. And Ralph, welcome back onto the program. How you been?
Hey, great, doing well. And boy, Ben, I'll tell you what, if there's ever a week where we need to have uplifting, positive news, thanks to science and technology, it's this week with all the horrors going on in the Ukraine. And other things going on. So yeah. I'm just happy that you and I in this segment can bring some positive hope.
Yeah. Oh yeah, for sure. I mean, if people want to, kind of hear more about that, I mean, yesterday's show was, yesterday and Wednesday's show was a bit more about that. I mean, Ralph, it's kind of weird that, like, obviously, Craig was doing this more during the Iraq war and Afghanistan and all that kind of thing. And, technology obviously played a part, but as far as consumer technology goes, it didn't really, come up that often. Like, there was a war going on, and we also, here's a printer, stuff like that. But this, this conflict, what's happening here, Ralph, it's shocking to me. And this is, before we get into the news and everything, it's shocking to me how much, like, we did a story about how the invasion was first spotted on Google Street View because they said there was a traffic jam on a road. It's there are websites that are being taken down thanks to DDoS attacks. Like, consumer, concerning things are making its way into, I guess, kind of my beat and my news feed. And that's surprising.
Yeah. No, you're so true. My wife, in fact, this morning was saying this is the first major European theater war has social media mixed into it. So she was saying the Russians, in this case, in terms of propaganda, they can't hide. It's not possible. So the world is witnessing this thanks to social media. So everyone, lately, the past year, has been very down on social media, and I get that, and I understand that criticism rather. Right. But in this case, this is helping, I think, bubble up the truth to the surface. So interesting developments, to say the least.
That was one of my favorite stories from yesterday. Thank you for reminding me. Was that there was Russian propaganda saying we shot down this helicopter, this armored personnel carrier or whatever, and within a couple of hours, random people on Twitter just had picked apart the image, had found the exact spot that it was shot thanks to the location, stuff like that, and shown that this was all fake. There was the Ukrainians don't even own this type of vehicle, and it stuff like that. It's there. Like, oddly enough, there's a part for everyone to play, and even if it's just paying attention and keeping your eyes about.
Amen.
But you don't have to pay attention 24/7. You can let your guard down. You can relax a little bit. And of course, with that, I think Ralph is a great one to do that. So, Ralph, yes. You have submitted a number of great stories, about 5 of them this month, and I'm looking forward to them. And let's start with number 1.
Yeah, sure. So what we've got today, 4 of our 5 stories today have kind of a medical or health related theme. And one story is about a real potential breakthrough for solar energy technology. So it's kind of an interesting grab bag. And let's get off to this first one. Story 1, MIT's new robotic platform can dramatically speed the evolution of microbial populations to help cancer and other medical research. Great story I got from MIT newsroom. And wow, like Ben was saying, friends, come to get the show notes. We have the links, we have the images. You can dive in deeper. What we're going to do is give you the Reader's Digest, very condensed, layperson friendly interpretation of these stories. But if you want the details, come and get the show notes because it's really important. And this first story is admittedly pretty darn geeky. So here we go. So like I say here in my notes, okay, this is geeky stuff, but very important for medical research. And first, some background. Let's set the stage. To support a wide range of medical research, scientists in recent years have developed ways to accelerate the evolution of microbial populations, such as, for example, a community of bacteria in the lab. So it's the idea of accelerating evolution, right? Accelerating mutations. So the process of accelerating process, I need to evolve my voice. The process of accelerating evolution is called directed evolution. Directed evolution is being increasingly used to accelerate genetic mutations and thus help engineer new or improved enzymes and whole genomes. And genomes refers to the complete set of the genetic information in an organism. And for example, directed evolution has yielded new antibodies to treat cancer and other diseases. But to date, directed evolution has been limited to small scale procedures. And that's all going to change thanks to Massachusetts Institute of Technology, aka MIT researchers, who recently announced a robotic platform that supercharges the process of directed evolution. And MIT's new process outperforms current techniques by making it possible to conduct 100 times as many directed evolution experiments in parallel. That's the key, giving many more microbial populations the chance to develop new molecules that could help lead to breakthrough medical treatment discoveries. Now, we promised you some uplifting news. There it is.
Hey, and being able to speed up the process. I guess, Ralph, back in the old days, they just kind of had a bacteria colony under a light and, just kind of waited for it all to happen. Now they can actually, kind of push it a little bit faster. And reading through, just kind of glancing through the article, I saw that they were even using things like Prance and CRISPR, which are two more of these technologies as well. I mean, they're medical breakthroughs. You already come on the show. In the past 5 years alone, there's already been so much research and unfortunately not that silver bullet to kind of beat cancer, but people are so much better off today than they were 5 years ago. It's just, you just, Ralph, I guess you just don't know it until you have to go through the treatment yourself.
Oh, isn't that the truth? Yeah. So there's, again, cause for hope and to look forward to the future.
Looking forward to it. And okay, so there's story number 1, and there you go. So now story number 2, we can go ahead and jump on over to something that hopefully everyone here can use, because Ralph, I don't know about you, but we recently had like an estimate for solar panels to be put on the house, and I don't need to go to college anymore, but thank goodness, because it would cost like 5 college education. Solar panels are so crazy expensive. I'm hoping that the technology really proliferates better, and this might help it.
This might help it, and especially in terms of reducing bulk and weight of solar panels and so forth and so on. So we're jumping ahead. This comes from SciTech Daily. The headline here is Stanford University scientists have created an ultra-thin, lightweight alternative to silicon chips for solar panels. Wait a minute. Let that sink in. An ultra-thin, lightweight alternative to silicon chips for solar panels. This is really wild. So what if you could have impossibly thin, flexible solar panels as an alternative to today's silicon chip-based solar panels, which are bulky, heavy, and not flexible, right? So solar panels so thin and flexible, they can be used for mobile applications, from self-powered wearable devices and sensors to lightweight aircraft and electric vehicles. You got me. I'm into this. Mm-hmm. That's what a team of scientists from Stanford University recently announced. Their new super thin solar cells can be made into sheets, ready for this, 15 times thinner than a sheet of paper. What? Look at the picture that's in the show notes, everybody. If you're able to see this, you can see the little needle nose pliers pulling up a little. It really does look like
a sheet of cellophane. Yeah.
Yeah. Isn't that something? It almost kind of looks like that clear packing tape stuff, right?
Yeah.
Anyway, the key to this stunning achievement is the use of transition metal dichalcogenides. And I hope I'm saying that right. DICHALCOGENIDES. And I'm not even going to try to butcher that again. Go to the article. You can get more details and you can Google that as well to create. So they're using this transition metal dichalcogenides to create a new family of 2D nano sheets with atomically thin semiconductors. Oh my gosh, thin and flexible. There's so many more details in the article, as I've been alluding to, we don't have time to dig into, but I wanted to highlight this breakthrough, and it could literally change our world. And so please go to the article, dig in deeper if you're so inclined. There's so much information that I can provide today.
So, and just to kind of recap real quick, the real breakthrough in this is, well, I guess the end result of this is, Ralph, is it more solar panels in more places, or is it more efficient ones everywhere else? I mean, what is the hopefully end result of thinner solar panels?
I didn't pick up offhand that it would increase efficiency necessarily. I think it's more to do with more possibilities with this flexible thin material. It opens up, you could maybe have a solar powered jacket or so. I mean, there's just unbelievable possibilities. Or you could apply this material because it's flexible. It could be applied to the wings of aircraft. It could be do this and that, on and on and on. There's just endless possibilities, I think. And hopefully this is viable. Hopefully this could be produced commercially in a viable, affordable way. We'll see. But this is groundbreaking. Just the beginning of this new trend.
So solar panels in more places. I don't know if you've seen the electric cars that have the solar panels kind of built into the roofs of them, but hey, maybe a super thin panel would be super helpful in that kind of situation as well.
Well, what if you could make it somehow, and it maybe not possible in this case, but transparent, so it could be a coating on windows. Imagine office buildings with windows with this sort of stuff, or window shades that would have it, and when you need to pull down I mean, I think maybe there could be, imagine office buildings with window shades, big, tall office buildings or apartment complexes. And they're the sun facing side. People are going to pull down the shades anyway. Well, put this stuff on the side of the shade that's facing the window, right? The sun, and endless possibilities because it's thin, flexible. That's the thing that's so exciting.
Putting technology where otherwise you could not before. And that is, I feel like that's going to bring in a lot of change in the near future. So there's that one. Story number 2. Story number 3, speaking of change in the near future, I mean, like, I think we've all worked, either sawed something or, just had sawdust lying around. And I always thought, wow, this stuff would be so cool to light on fire because I'm, a pyromaniac. And I'm sure everyone is like that. But sawdust is an annoyance. It's dirty. It's something you just have to get rid of. And, well, I may be wrong. Story number 3.
Yeah, well, I'll say this about sawdust. Being in the Northwest, of course, the lumber industry is huge for us. And sawdust in our world often winds up in particle boards, right? So they're taking the sawdust and glues and so forth and presses and making boards, the shelving boards that you see at your Home Depot or wherever you go for your lumber supply. But here's the story. This comes from Science News. A new sustainable disinfectant made from sawdust kills deadly microbes. What? Wow. Okay. So if you think sawdust is only good for making particle boards, as I said a moment ago, think again. Researchers at the Fudan, that's Fudan University in Shanghai, so this is coming from our Chinese colleagues, have created a new sustainable disinfectant made from sawdust and water. Those are exotic ingredients. Sawdust and water that can knock out more than 99% of some disease causing microbes, including the likes of anthrax and several strains of flu. And there's more. The new low cost formula could provide a much needed and more environmentally friendly disinfectant alternative to such harsh things as bleach, right? Mm-hmm. Today, many green or environmentally friendly disinfectants rely on a compound called phenol or its chemical lookalikes, which are costly and energy intensive to make. And it turns out that phenol structures, guess what? They abound in wood as part of the large branching molecules that make a tree's cell wall. So the researchers at Fudan University wondered if sawdust waste could provide a greater source of phenol. So here's what they did. The researchers cooked mixtures of water and sawdust for 1 hour under pressure and filtered the result. And the pressure cooker process broke down the molecular chains in the sawdust, releasing the antimicrobial phenolic molecules. So again, let's say that again. The pressure cooker process broke down the molecular chains in the sawdust, releasing the antimicrobial phenolic molecules. In one experiment, the team tested the sawdust concoction for its ability to kill E. coli. Heard of that one? The result, depending on the sawdust-based disinfectant's level of concentration, it could zap more than 99% of this microbe and many, many others too. So, wow, your lowly sawdust, which when I was a kid, you'd usually put it on the garage floor to soak up leaking oil, or at school, kind of a gross out here at school, sawdust was brought out to cover up when a kid threw up on the floor, or, that kind of stuff. And then later they started making particle boards and furniture made out of particle board and so forth. We're all very familiar with that. But here's this great new, I guess you'd call health/medical use for sawdust of all things. Sawdust and water. There's an exotic combination.
Chemists are a different breed where they say, we use a lot of this chemical. Where else is this chemical? Oh, it's in wood. Let's get it out of there. And I guess a pressure cooker of all things is the key ingredient to getting it out of there. Ralph, now clearly I don't think they're recommending people go out and cook their own sawdust and make their own disinfectant because, I'm betting it leaves behind a residue and, there might be a lot of other problems.
Yeah.
But, as they were saying, phenol was costly and energy intensive per your notes. Maybe it could be a little bit more affordable by getting it from wood waste. So very cool. Yeah.
Pretty cool, huh?
Yeah, and I just realized I just had it up on my screen for a little while there, but story number 4, for those who didn't peek and cheat, this is, and there's actually so many advances in robotics, and don't get me wrong, they can put together cars, they're super good in exploration and, drone scouting and stuff like that we cover here on the show, but robot surgery. Ralph, I know that you went through a fairly big surgery a number of years ago, and I think that one was still performed by people. But how comfortable would you be about the next one? And it looks like something that should be lifting a tire onto a car.
Well, yeah, I that's a very good way to personalize this. I think, and we'll find out in this article, and we're jumping ahead a little bit. Right now, the researchers behind this story say it'll be still for the time being a helper, an aid to the lead surgeon. But we're jumping ahead. Let's get the headline here.
Let's go.
Experimental robot surgeon. So an experimental robot surgeon can operate without human help. And there's even more to it that's astounding. Several sources for this story for me. One was gizmodo.com, had a great friendly version of the story. And then Medical Life and Sciences News had more details. We have the links to both. You can check those stories out. You can see the picture in the show notes here of the robotic system in question. So here's the deal. Researchers at Johns Hopkins University recently announced that for the first time, their robot surgeon performed a delicate abdominal surgical procedure on a pig without the assistance of humans. And why pigs? I think I understand that pigs their skin, their anatomy, and so forth. There's elements of their body that's very close to human beings. And
right.
I think people or pigs, I get that. Also chimpanzees share very close DNA with those guys. Basically cousins.
To kind of link it to something else that people may have heard of was Elon Musk and his whole brain chip thing. They're testing those on pigs as well. So pigs are a pretty good analogous to humans.
Yes, in many medical ways. Yes. So of course, the use of robots in operating rooms isn't new. That's not what we're saying. However, the university smart tissue autonomous robot is the first robotic system to plan, adapt, and execute a complex soft tissue surgical procedure without any human intervention. Let that sink in. This is the big deal. And here's how it worked. Using its highly advanced artificial intelligence, sophisticated visual guidance system, specialized suturing tools, you're going to find out that's the key here in this experiment, and articulate robot arms, which are shown in the photo, the robot surgeon autonomously performed on a pig one of the most intricate and delicate tasks in surgery, the reconnection of two ends of an intestine. Soft tissue, it's like with vein grafting and that sort of thing. Mm-hmm. This is incredibly challenging to sew that stuff together. Can you imagine? I can't even begin to imagine. The researchers noted, however, that for now, their smart tissue autonomous robot will continue to play the role of assistant to human surgeons. However, the Johns Hopkins team says they can envision a future where autonomous robotic surgery systems could help treat patients in trauma situations on the way to the hospital. Now, the on the way to the hospital thing, to my mind, I'm seeing an ambulance and it's bumping around, hitting potholes and all. Okay, maybe. Here's what I think is interesting. What if you had these systems someday that are even more developed and more advanced? If we want to live on the moon, for example, and what are you going to have a surgeon there in residency? What if there's a problem, somebody gets injured or whatever? Wouldn't it be amazing to have a smart, incredibly smart and capable surgical system like this in place in an area or a battlefield, surgical disaster zones, that sort of thing? That's what came to my mind when I thought about this story. And I want to emphasize one more thing that they talked about that makes this so important. Thanks to artificial intelligence, this thing planned, adapted on the fly, and executed this soft tissue surgical procedure of putting together two bits of intestine. Planned and adapted and what?
Yeah.
I mean, wow.
Oh, yeah. And by the way, I think we actually have a picture of what a robot that would travel in space and adapt to a situation and treat people. We actually have a picture of what that would look like if you're watching the screen.
Yes.
There it is. Yes, it would look exactly like like the Doctor from Star Trek Voyager, or any other robotic android. Right. And in a funny way, it is the precursor to something like that. Great show. I actually love that show. But you kind of took it to space and exploration, and it's great for science and tech trends and what you do. But I also kind of took it to, imagine if every CVS, random drugstore, whatever, had a little room off to the side and was like, "Hi, I'm Ben. I'm checking in for my my 3 p.m. surgery," and you just walk in, everything's sterilized, it does the surgery right there, and you walk out, and surgeries become mundane. Life-saving medical care becomes scheduled and routine. That would be really cool.
Yeah. Well, for emergency rooms, urgent care facilities, like you say, and so forth, I think I can see that, and it could be a real deal breaker for many things in medical.
Yeah. For sure. So there's story number 4, and we are more than happy to wrap it up with story number 5. And Ralph, I gotta say, everyone out there who may think that masks are like, I don't know if you've ever seen the videos, Ralph, where people like tear apart masks and they're like, "Look what is inside these masks." And the only ones I've ever seen are jokes where they pull out like full-blown iPads and smartphones and stupid stuff like that out of masks. But they're, in reality, N95 mask or whatever we've been using for COVID, they're just like fiber. They're fiber. They're cloth layered over each other, prevents the little viruses and the bad stuff. But you never really know how well it's working. Although I know because I see everyone, Ralph, do that little twist thing behind their ear, and so it creates the two little air channels. And I'm like, man, people have become so creative on how not to use masks. But for the people, that's
funny you say that.
yeah. But for the people it actually matters for, knowing that your mask works could be the matter of, saving yourself or protecting someone else. It's important to know when it works well. So story number 5 helps with that.
Yes, it does. And the headline here is New Sensor Tells You How Well Your Mask is Working. This comes from Scientific American. Again, we have pictures and please, if you're able to see what we're talking about right now, you're watching us in a video mode. Look at the picture of the little tiny chip that's shown just resting up against a mask. It's not how that would be deployed, but they're just trying to show you the scale and so forth. And we have a video too. There's a link in the show notes to a video for this. So here's the story. Researchers at Northwestern University have developed a lightweight, reusable sensor that clips onto a face mask. So it clips onto your mask to monitor how well it's working. Think about healthcare workers, doctors, nurses, hospital caregivers, retirement home caregivers, all these. I mean, there's an endless number of people that need to know how well is my mask working and so forth. So the device is called FaceBit. FACE bit, almost like Fitbit, right? Uses several sensors to detect leaks and records wear time while continuously measuring the user's heart and breathing rate. Wow. The goal is to help healthcare and other workers who wear face coverings throughout the day monitor the effectiveness of their mask. And about the size, this thing is about the size of a quarter, and you can see it on the image that Ben's showing you. About the size of a quarter, the FaceBit electronic sensor attaches to a mask with a magnetic clip. Very simple. A pressure sensor detects leaks. Very important, indicating how well a mask is fitting. And by the way, I can really relate to this. I'm one of those unfortunate people that has to wear a CPAP machine so I don't die in the night from lack of oxygen. And boy, the whole bit about how well your seal is very critical. My machine lets me know if it's not happy. So this pressure sensor detects leaks, indicating how well a mask is fitting. A Bluetooth connection transmits its monitoring data to a companion phone app. That's cool. And the device is powered by a battery, which is I love this. You're going to love this. It's powered by a battery, no surprise, which is supplementally charged with energy harvested from the mask's motions as the wearer moves and breathes. How clever is that? This lets FaceBit, the little device, function for at least 11 days at a time before needing a traditional recharge. And so for people in the medical industry, hospitals, on a doctor's office, police force, you name your profession where people have to wear a mask for 8, 9, 10 hours a day. Wow. How cool is this? I love this story.
Yeah, and of course, looking at the diagram here, it's amazing how much they're able to squeeze onto such a little board.
Oh, gosh, yes.
Man, and it's super cool. It tracks every possible thing that you can, that you could want to know, and it even has, like you said, a little battery clip, so you could even just swap out it looks like a coin battery as well to charge it. So yeah, very, very cool. And FaceBit, again, very much research. I mean, just looking at these images here, version 0.1, still very much in research, but it's one thing to have a mask and say, wear this, you'll be safe. And it's another thing to know, you are safe, period. We know that for sure. So very, very cool stories from story 1 to story 5, Ralph. That was a great host of articles that you got. And I'm thank you for the distraction, as we said, that we opened the show with.
Yes.
This was fun.
It. Yes, it was. And once again, I hope we've been able to, Ben and I, we hope we've been able to take you to a more positive, uplifting space than the world we're living in now.
Yeah, exactly. So with that, the music is playing, and everyone, we hope that you enjoy your weekend, you do something fun, and you just have a good one out there, everyone. ComputerAmerica.com will have the show notes, and again, a link over to Ralph, or you can just go to Ralph Bond Wicks, search that in Google, pop right up. But as always, it'll be in the show notes. Ralph, we'll catch you here next Friday.
Okay.
All right, everyone. So until next time, have a great day. Thank you so much. And have a good one. Bye-bye.